2.7 Inverse Functions Day 2. Your learning goal is that you will be able to build functions that model relationships between quantities from existing functions. In this lesson, we're going to start off with the horizontal line test, which is used for inverse functions. And basically what this test does is it tests to see if f, or the function, has an inverse. And that means that there is no horizontal line. And let me type this for you. And so the test says that no horizontal line, well, if no horizontal line that intersects the graph of the function at more than one point, then f has an inverse function. So it should say if there we go. And we call that, remember we use this symbol, F inverse. And I'll just do some so you can see how it looks. I'm just going to draw a couple of graphs, and then you're going to indicate whether or not it has an inverse function. This is A, B, C. Okay, looking at example A, does this graph pass the horizontal line test? And all you have to do is take your pencil horizontally and see if this passes. So this one has an inverse function. And let's try B. This one does not pass because it hits it in more than one point. This one is no inverse function. And then C. C has an inverse function. So only A and C have an inverse function. Looking at example 2, you can use a graph to draw the inverse. So the first thing I would suggest is you label the points given. So this first point is -2, 4. This point is -1, 2. And our third point is 0, 1. And remember, inverse means you take the function f and you switch the x and y values. I didn't even switch. So y becomes x and x becomes y. So now this new point would be 4, -2. This point would be 2, -1. And this point would be 1, 0. So now I'm going to plot those points. So 4, -2, 2, -1, and 1, 0. And then you'll graph this new graph. Now, very important, when you draw it, the inverse, the mirror, just to let you know, is the line y equals x. That's your reflection line. So when I draw this graph, that means everything has to reflect. So when I draw it, it'll be this way. That way the points, when you fold them over that pink line, they're going to reflect each other. And so if you draw that line, that y equals x line, which goes right through the origin, that will help you, excuse me, I should have did it in pink. That will help you draw your correct inverse function. The last example, we're going to find an equation for the inverse, graph both functions, and then state the domain and range for both functions. So let's start off, this is example 3a. We'll start off with a linear function. And we're going to go through the steps to find the inverse. Remember, step 1, you change f of x to y equals. Step 2, you switch x and y. Step 3, solve for y. So I'm going to add 3 and divide by 2. Step 4, I'm going to change y to the inverse symbol of f. So this is our inverse function. So we did the first part. Then it says graph both functions. So first I'm going to graph f, and it's linear. So I'm going to use slope-intercept. So I'm going to start at -3, and then I'm going to go up 2 over 1. Since it's a line, you only need 2 points to graph the line. Then they want me to graph, so this is f of x. To graph the inverse, I'm going to switch these points. This is 1, -1, and this is 0, -3. So my new points will be -1, 1, and -3, 0. -1, 1, and -3, 0. So that line would be going this way. And remember, there's your reflection line. Okay, so then they want us to state the domain. Well, for f, the domain would be -infinity, +infinity, because there's no square roots and no fractions. The range will be the same. Now, when you do the inverse, you would switch. Your domain would be your range, which is -infinity to +infinity. And your range would be your domain, which is -infinity to +infinity. So remember, inverse means we switch x and y. So for domain and range, you have to switch. So range becomes domain, domain becomes range. Okay, B. This is a parabola, and because parabolas do not pass the horizontal line test, we have to restrict the domain. Restrict domain. That means that we're only going to graph 1/2 of the parabola. And since it says smaller than 0, we're only going to graph the left side. Okay, so just remember that. But first, let's find the inverse. Step 1, change y, or f of x, to y. Step 2, switch the x and the y. Notice I don't change the square now, I'm just switching x and y. Step 3, solve for y. So I'm going to add 1, and then I'm going to square root. Now, usually we would have plus and minus, but because our domain is restricted to the left side, that means we can only use the negative. So it's very important that you look at this and that it matches this. And then step 4, change y to the inverse symbol. And then this is our inverse. So now they want us to graph the original one and its inverse. All right, so the parabola, remember we start off with 0, 0, 1, 1, and 2, 4. But we're only going to do the left side, remember, because it says x is smaller than or equal to 0. So we can't use anything greater than 0. And then we're going to move those points down 1. So actually, I'm not going to connect this one because that's my parent graph. So I'm going to move it down 1, down 1, and down 1. So those points would be 0, -1, -1, 0, and -2, 3. Now I'm going to graph the inverse. The inverse would be -1, 0, 0, -1, and 3, -2. So here's 3, -2, 0, -1, and -1, 0. So now this side will be going this way. Because remember, we have that reflection line. All right, domain, f of x. My domain would be, since they restricted the domain, we can only use smaller than, because it said x is smaller than or equal to 0. So that'll be -infinity to 0, including. And then my range would be -1, because if you notice the pink line, I'm going from -1 up to infinity. Okay, to do the inverse, remember the domain and range switch. So now my domain is -1 to infinity, and my range is -infinity to 0. So don't forget, for your function and your inverse, the domain and range, they switch